Welcome back, everyone. Uh, Let us see how to solve this rational equation. It says what is the solution set of 1 minus 1 over x, the whole over 1 minus 1 over x squared is equal to 3x squared minus 1x over 1 over x. So first of all, we have to simplify this whole expression and write it as a form of p of x over q of x form. The same manner we have to do this also. So let us see step by step. First one, it says 1 minus 1 over x, the whole over 1 minus 1 over x squared. This is numerator, and this is going to be the denominator, the down part. So how to minus this one? 1 means just over 1. Here also it's over 1. By crisscross, 1 times x, it's going to be x minus, and 1 times 1, it's going to be 1. The whole over x is the whole numerator part. Over the same manner here, crisscross, 1 times x squared, it's going to be x squared minus 1, the whole over x squared, which is denominator part. This is the same as x minus 1 over x times, you can flip the denominator part here, it's going to be x squared over x squared minus 1. We can cut x with x here. We can cut this x with x squared and then 1x remain. And this denominator, x squared minus 1, we can write as x minus 1 and x plus 1 for. We can factorize because this is difference of square. Then x minus 1, we can cut with x minus 1. Then finally, what remains? X over x plus 1 remains. The first numerator or the first expression is simplified and written in the form x over x plus 1. Done. Now let's go on the second part. Second part, again it says x over 1 plus 1 over x. This is it, which is equal to x over, again, crisscross here, x over, let's write it properly, x over crisscross, x of x plus 1 over x. This is the denominator part, which is x times, you can flip it again, x over x plus 1, this means over 1, is equal to x squared over x plus 1. Don't forget, in every step we have to exclude the 0 point of the denominator. Till now, what are the undefined points of the denominator? What makes the denominator here? 0. X must be different from 0. It can't be an answer. 0 cannot be an answer for our solution. And even here we cancel x minus 1 by x minus 1. That means x also different from 1 and still different from negative 1. Those numbers are undefined point. Therefore, now let us combine or let us substitute. The first part here, we are going to substitute x over x plus 1. And here, the last part, we are going to substitute x squared over x plus 1. Let's go to the new page. Okay, so as we said before, x over x plus 1 is equal to 3x squared minus the last part we said already, x squared over x plus 1. We can check. Here it is. The first part already x over x plus 1 is equal to 3x squared minus, it says, and the last one x squared over x plus 1. Okay. Now, the next step, what to do is denominator 1, the LCM. The LCM of the denominator, x plus 1 found here, it's 1 here, and x plus 1, everything. Nothing will be factorized in the denominator. It is just one linear expression is found, so we will take the LCM as x plus 1. And what makes this x plus 1 0? It's a negative 1. We already restricted. So multiply each of them by x plus 1. So when you do that, this x plus 1 will cancel this x plus 1, and what remains? X is equal to, and 3x squared multiply with x plus 1, 3x squared will be multiplied with x plus 1 minus, here also x plus 1 and x plus 1 cancel out and x squared remain. Then let us finish it, which means x is equal to 3x cubed plus 3x squared minus x squared. Again, x is equal to 3x cubed plus 2x squared. We can take the difference here because they are like terms. These two are like terms. And the next step, let's collect everything. What do we have now? 3x squared plus 2x squared, I mean 3x cubed here, minus x is equal to 0. We can bring the x and make it together. And then take out common. When you take out common, let's go new page. Okay, when you take out x as a common, 3x squared plus 2x minus 1 is equal to 0 remain. Remember the previous page here. So we can take out x common from each. So here just 1 left, here 2x left, here 3x squared remains. Therefore, what to do now? The product of the two 0 means x is equal to 0, or 3x squared plus 2x minus 1 is equal to 0 remain. But x is equal to 0 will be one answer. Just keep it. And let's go on to the next one. This is a quadratic. To solve this quadratic, we can apply formula or product sample factorize. We need to think of product 3 times -1, which is -3, and sum the middle term, which is 2. So what are these two numbers? When you multiply them, they will give you -3, and when you add them 2. What are these numbers? -3 and 1. -3 times 1 will be -3, and -3 plus 1 will be, +3 and -1. Yeah, better. 3 times -1, -3, and 3 plus -1 will be 2. Therefore, we can write it 3x squared plus 3x minus x minus 1 is equal to 0. What do we do? The middle term 2x will be split and written like 3x and minus x. Then just group the first two together and the last two together and take out common. What's common here? 3x will be common. Then what remains? When I take out 3x here what left? Just x left, plus 1 remains here. Again, what's common here? The last two, it's just negative. -1 will be common, so x plus 1 remain is equal to 0. Still, we can extract common for this expression. X plus 1 will be taken as a common. Okay, let's go on the next page again. So when you take out x plus 1 as a common, what remain? 3x minus 1 remain is equal to 0. Let's check again. As I said now, if you take out x plus 1 and x plus 1 common, what left? 3x minus 1 remain. Okay, let's go on. So that the product of the two 0 means we can say x plus 1 is equal to 0, or 3x minus 1 is equal to 0. This means x is equal to -1, the other answer. Or again, shift the 1 to the other side, 3x is equal to 1. That means divided by 3, x is equal to 1 over 3. This is the third answer. Now our solution said, remember, x is equal to 0, we got it before, x is equal to -1, and x is equal to 1 over 3 we have. But we state the domain is equal to real number, but without, we say 1, -1, and 0. So which numbers are found here in the domain, in the excluded part? 0, it is under the excluded part, we will ignore this. And -1 also doesn't work because it's undefined point. Finally, our solution set will be just 1 over 3. This is going to be the answer. So let's get back and see once what do we do. First step, we have to write these two expressions and p of x over q of x form. And for that matter, we did them separately, and then we arrived the first one x over x plus 1, and the last one it is x squared over x plus 1. And then we go to the next page, we wrote them together, and then we try to find the LCM because this is now formal rational expressions. And then we try to find the LCM of the denominator, which is x plus 1. Then we multiply each of the terms. Then what happened? X plus 1 cancel in the first and x left. In the second, 3x squared will be multiplied with x plus 1, as you see here, and then minus x squared because x plus 1 cancel again. Then we reshuffle and we collect, and finally we arrive some kind of quadratic, as you see here, because the product of the two equal to 0 means x is equal to 0, one answer. Just keep this one and then let's go on. How to solve the quadratic? We apply here product symbol or factorization process. You can apply and you can find by the formula. Remember the formula of quadratic equation, which is negative b plus or minus the square root of b square minus 4ac the whole over 2a is a formula to find quadratic equation, the solutions of quadratic equation. By identifying a, b, and c, you can apply this formula. And then finally, we apply a factorization process and we arrive here. The answers are -1 and 1/3. So finally, we do have three answers: x equal to 0, x equal to -1, and x is equal to 1/3. But 0 and -1 cannot be answered for our rational equation because these numbers are already excluded. They cannot be the domain. They are undefined points. Therefore, the solution set will be 1/3. Thank you for watching. Keep watching. In the next video, I'll come back with another concept. Thank you.